Okay, 8.12 is still the washer method, but now we're revolving around other axes, so we're different lines. Okay, whether that's a vertical or horizontal line, which means we're no longer going to be taking our radius and subtracting 0, which was the x and y axis, but instead we're going to have to take our radius and subtract it from the line that we're rotating around. Okay, so whether that's the vertical or horizontal line. The first part here just has us rewrite the formula for volume. Okay, so this is volume is equal to pi times the integration of a to b of r of x squared minus little r of x squared dx, where again the capital R is the outside function, lowercase r is the inside function. Okay, so since we're dealing with two functions here and a separate line for rotation, remember when we're talking in terms of x, we're going to always do the top minus the bottom function. Okay, if we have this in terms of y, we're going to do right minus left of the function. Okay, so number 1 says find the volume if the region is enclosed by y is equal to square root of x and y is equal to x squared, and it's rotated around the line y is equal to 2. So that's the first thing I'm going to draw is that line. Okay. And I know that we're going to rotate around it. Okay. So notice that since this is a horizontal line, we're going to be looking at the x-axis because it matches, they're both horizontal, which means we're going to use that to find our boundaries. So our boundaries are going to start where and end where? If we're looking at the x-axis. 0, right? We're looking at the intersections of that area. 2, 1. Oops. Okay, remember we're looking at that little area. Okay, the next thing we have to do is we need to do the mirror image across that line y is equal to 2. Okay, so notice that the quadratic here is 2 away from that line. So when we draw our quadratic on a mirror image over that line, it also has to be 2 away. Okay, so when I draw that, it's going to look like this. Okay, notice I do not need to draw the entire thing, or it's just going to look like a graph of lines. Okay, really what I'm drawing is this. Okay, notice all I really care about is the mirror image of this area. So that's why I only drew that part. Okay, the next thing I'm going to do is I'm going to do the mirror image of the square root of x. Okay, which means it's going to flip over that line, and again, it's still 2 away, so it's going to be like this. So now I have both of these areas, and if I was to take both of these areas and rotate it around y is equal to 2, it's going to again form that washer style where we have a smaller circle and a larger circle. Of course, drawn a little better than what I did, but you guys get the idea. Okay, so then from here, we're going to write our equation for the volume. So this is volume is equal to pi integral from 0 to 1, because we said that is our boundaries. Okay. And then now we're going to do top minus bottom. So notice that both of our functions here in the original one are on the bottom. The only one that's on the top is this line. Okay, so if we do top minus bottom and then top minus bottom outside, which one would be the outside function? 1 or 2? 1, that's the outside function. Okay, so the quadratic. Okay, so when I write this, it's going to be 2 minus x squared squared. Okay, again, this is top minus bottom and outside. Okay, then I'm going to subtract and still do top minus bottom again, but I'm looking at the inside function, which is going to be what?
2 minus the square root of x.
And then squared, and then dx. Okay, so this part over here is still top minus bottom, but now this is the inside one.
Where did the 2 come from?
The line, y is equal to 2. So that is our top function. Okay, so when you're comparing top and bottom, you're always going to look at the line that you're going to rotate around and then where your original area is. So in this case, our original area was below the line.
Okay.
If our original area was this one above the line, okay, then that would be our top, and the y equals 2 would be our bottom.
Why is this equation in terms of x if it's revolving around u? Did I answer my question? Yes, I did.
Got it? Okay.
Got it.
Okay, so again, just like before, you can integrate this, practice integrating, plug it in on a Desmos, see what answer you get, test your integration skills. But here, I'm just going to be writing the volume. On these type of questions that are multiple choice, they only care about you setting up the problem, not necessarily solving the problem. Okay, if you had an FRQ like this, most likely you'd have access to Desmos. Okay, number 2 says find the volume if the region enclosed by y is equal to x squared plus 1 and y is equal to 2x plus 1 is rotated about the line x is equal to negative 1. Okay, so the first thing I'm going to do is I'm going to draw that line x is equal to negative 1, which is right here. So notice that this is now a vertical line versus a horizontal line, which means I need to make sure my equations are in terms of y, so I need to get x by itself, okay, because it's going to be rotating around that line. Okay, so then I take my equations, y is equal to x squared plus 1. If I solve this for x, that's subtracting 1 to the other side and then taking the square root. So I have plus or minus the square root of y minus 1. And then the other one, y is equal to 2x plus 1. Solve for x. I get y minus 1 over 2. Notice it's the same equations from the last notes. Okay. So then once I have this in terms of the correct variable, now I'm going to do the reflection or the mirror image over this x equals negative 1 line. Okay, so I have this area here, and I need to put that on the other side of that line. Okay, so looking at that, if I look there at the bottom where I have my first intersection, it is 1 away. So I'm going to make sure that this one is also 1 away. Okay, and it's going to be reflecting to the other side, and it's part of that quadratic. Okay, the other part is the line. The line is also 1 away. And then when I mirror it over the other side, I'm going to get something that looks like this. So again, my mirrored image of my original area should look the same. About, right? Because we're not all professional artists. Okay. And since this is going to be rotating around this x equals negative 1 line, that means when we're finding our bounds, we care about the bounds on the y-axis. So what would those bounds be?
1 to 5.
1 to 5.
How do I know this?
And again, since we are in terms of y, we're no longer doing top minus bottom, but instead right minus left. So if I write my volume equation, I have the volume is equal to pi times the integration of 1 to 5. Okay, and then again, it is my right outside function. Okay, so both of these functions are on the right. My line is on the left. And then out of those two functions, which one is on the outside? The curve or the line? the curve. So this is going to be the square root of y minus 1 minus negative 1 squared. That is the outside function on the right, which is the curve, minus the left function, which is that x equals negative 1 line. Minus, and then I'm going to do the same thing, but with the inside function. And so I have y minus 1 over 2 minus a negative 1 squared dy. Okay, again, you can simplify this and integrate it on your own. Compare it to when you plug it into Desmos and see if you get the same answer.